So you forgot how to draw molecules. Let's look at carbon dioxide as our example. Carbon dioxide is CO2. The first thing you want to do is figure out how many valence electrons they have. So, this compound is made up of 1 carbon and 2 oxygens. If you look at the periodic table, carbon is right here. It has 4 valence electrons. Oxygen has 6 valence electrons. So they end up having 16 valence electrons. This is how many valence electrons they have to work with. Now, how many valence electrons do they want? So carbon only wants 8. Oxygen wants 8 each. So 2 times 8, 16. So 16 plus 8 is 24. Now, since they only have 16 and they want 24, you can tell they're short. So we can subtract 24 minus 16 to figure out that they need 8 electrons. So this is how many electrons they don't have. So what they're going to do is they're going to share. And when they share, they form bonds. And each bond is 2 electrons each. So if I take the 8 electrons they don't have, divide by 2, that's going to give us 4 lines or 4 bonds to draw. Every molecule is going to have a center molecule, so carbon is going to be in our center and oxygen is going to be on either side. Okay? Then one that's the one that is usually normally just by itself is going to be in the middle, and the other ones are going to be on the outsides. So with carbon in the middle and oxygen here, they have to be joined by at least 1 line. So these are 2 lines I've drawn. I wanted 4 lines, so I'm going to put the 3rd line here and the 4th line here. So now I know how many lines there are. I'm going to look at each one of these elements and add dots so that they all have 8. So carbon in the middle, we're going to start in the middle. So carbon has 4 lines touching it. So carbon has 8 electrons. Now oxygen has only 2 lines touching it. So oxygen right now, as I've drawn it, has 4 electrons. So that means I have to draw 4 more electrons. This oxygen is the same way. This oxygen has these 2 lines touching it, and so I'm going to draw 4 more electrons, so it has 8. All right. This is carbon dioxide as it's drawn. Now we're going to look at a compound that has hydrogen. So let's take a look at H2S. All right. First, we figure out how many electrons they have. So hydrogen, there are 2 of them, and each hydrogen has 1 valence electron each. So if there are 2 hydrogens and they each have 1, that means that's 2. Sulfur is right here. It has 6 valence electrons. And we have a total of 8 electrons. This is again how many electrons they have, how many valence electrons they have. So we got to figure out how many valence electrons they want. Now, sulfur wants 8, but hydrogen is an exception. Hydrogen wants only 2 each. So if there are 2 hydrogens and they both want 2, that means 4. So if we count them up, 8 plus 4, that's 12. 8 is how many electrons they have. 12 is what they want. So 12 minus 8 equals 4. This is what they're lacking. They need 4 electrons. So what they're going to do is they're going to form bonds. If I take my 4 divided by 2, that means they're going to make 2 lines. Put sulfur in the middle, hydrogen here, 1, 2, that's 2 lines. I don't have any more lines to draw because I've calculated the 2 lines. Now, starting in the middle, sulfur has 2 lines touching it. That's 1, 2, 3, 4 electrons. So sulfur has 4 electrons. I'm going to draw 4 more electrons here. Hydrogen has 1 line touching it, so that's 2 electrons, and hydrogen is okay with that. So hydrogen is fine with 1 line, and this hydrogen is fine with 1 line, and this right here is the molecule for H2S. All right, the last one we're going to do is a polyatomic ion. We're going to do the polyatomic ion nitrate, which is NO3 minus 1. So let's break this down. There's 1 nitrogen. There are 3 oxygens. And according to the periodic table, nitrogen has 5 valence electrons, and oxygen has 6 valence electrons. So they have a total of 23 electrons. Now at this point, this -1 right here, this -1 has to be added to the amount of electrons they have. So that right here is added to the amount of electrons they have, making it 24 electrons. This is how much they have. Now, what they want, nitrogen wants 8, and oxygen want 8 each. Okay, neither one is an exception. 8 times 3 is 24. 24 plus 8 is 32. So they have 24. They want 32. So 32 minus 24 gives us 8 electrons. This is what they're short. This is what they have to make up. So they're going to divide that by 2, and we're going to draw 4 lines. Okay. Nitrogen is by itself, so we're going to put nitrogen in the middle, and we're going to put oxygen, oxygen, oxygen. With 4 lines, we're going to get 1, 2, 3. Now that 4th line can go anywhere. It can go here, here, or here. All right, so we're going to put it there. It doesn't really matter where you put it. That's called resonance, where you can have that double bond here or here. But you have to have 4 lines, 1, 2, 3, 4. Now to finish this up, we're going to add those dots. Nitrogen has 4 lines touching it, so we don't have any dots to put. Oxygen here has 1 line, so we're going to put 1, 2, 3, 4, 5, 6, so we can have 8. This oxygen has this 1 line, which counts as 2 electrons. So 1, 2, 3, 4, 5, 6, so it has 8. This oxygen has 2 lines, so 1, 2, 3, 4, so it has 8. And again, nitrogen has these 4 lines touching it, so it has 8 already with no dots. Now, all polyatomic ions must be drawn with brackets, with the charge outside the brackets. This is the drawing for nitrate.